is Jeff Mucci with RCR Wireless News, and we are here today to talk about network capacity planning and how this core group of folks are going to help save the European carriers from the data tsunami and mobile video tsunami. So what I'm going to do is I'm going to give you some statistics about mobile data usage and mobile video usage, and I'm going to go down the line and introduce the panel, and then we'll get into the details. So just how severe is the mobile data and mobile video problem? Here's some stats. Ericsson, the world's top mobile equipment manufacturer, says there's going to be a 10-fold surge in mobile data video between 2015 and 2021, driven by, no surprise, YouTube, Facebook, Netflix. YouTube accounts for 70% of mobile traffic in many networks, and Netflix can reach 20% of network where network is available. 40% of YouTube traffic comes from mobile today, and that's up from 25% last year and 6% the year before. 500 million mobile devices and connections were added last year globally. 500 million. Global mobile data, this is according to the Cisco report, the global mobile data traffic grew 69% in 2014, equaling 2.5 exabits per month at the end of 2014 versus 1.5 exabit per month at the end of 2013. Finally, mobile monthly global data will surpass 24.3 exabytes by 2020. So we ought to start with somebody telling me what an exabyte really looks like. But let's get started. We've got a great panel today. We've got equipment manufacturers, we've got fiber providers, and we have a few specialists in wireless. So our first, now I've reversed things here, but Jay Lawrence joins us, CEO of NexxCom. Raise your hand, Jay. Thanks, Brady. He is a subject matter expert in ultra broadband high performance wireless networking, powered by their own radios. NexxCon delivers the highest availability and payload with the lowest latency, time to service, and cost of ownership, and have offices here in Europe. And I think there's going to be talk about more of plans for growth here in Europe. Our next, Craig Cubbon, not Cuban, but Cubbon down the end, is product manager for infrastructure services for Hibernia Networks. Hibernia owns and operates a global network, including connecting North America, Europe, Asia, serving 89 markets and spanning 25 countries. Rob Barlow, CEO of WireIE. They are an industry leader providing high availability, secure data over networks in rural and remote regions. We met last year. Interesting things going on in the Caribbean and the tar sands. And they do specialize in vertical markets like oil and gas. And finally, Roy Hirst is in technical sales for Xqueel, which is a privately funded engineering company, and they explore and develop optical solutions and networks for data communications companies. And the company, interestingly, it was founded and led by one of Cisco's co-founders, Len Bosak. Is that right, Roy?
That's right.
Okay. So let's get started by having each of the panelists, I'm going to ask them a question, we'll talk a little bit about it, and then we're going to go into some general conversations about network planning, capacity, latency, standards, and that sort of thing. But we'll start out with Hibernia at the end down there. Greg, what impact will high-definition video have on your network, specifically moving data from the core to the edge and back?
Sure. So we've obviously seen this enormous growth of mobile data, and it's impacting how we start capacity planning our network. I mean, just for the sake of what we're talking about with mobile data. I mean, mobile data is exploding, as we know, but a colleague of mine turns up with a 4K smartphone. He's going to use it to watch his 4K videos on, but really, is there need for such definition on a handheld? Yet it is putting a burden on the networks. It's available technology to use, so it will be used. This enormous growth of bandwidth is also going to drive up the demand. I mean, we know the pricing of bandwidth continuously drops, but the demand is ever increasing. So we are going to have to look at how we get better efficiency out of our network and how we deliver that network. So there's a lot of change going on in the marketplace. I think things like SDN are a future technology that we would be looking at. Very much internally, we are looking at optimizing, getting more efficiency into the platform, getting better leverage out of the optical spectrum that we have. Constant improvement, I think, is the message here. And of course that goes not just for core distribution of what is the globalized data, it's also how we get that globalized data from the core down to the edge and down to the radio networks. So it's this whole expansion of the distribution of that data, not just for us, not just the core.
Why don't you tell us a little bit about some of the customers you're serving and what are some of their, maybe give us an example of a customer's acute demand today?
Yeah.
Capacity.
So very much, we're seeing a big shift in our primary customers from the wholesale carrier market very much towards the mega growth web centrics. So the guys that run the big search engines, the guys that run the social media sites, and we all know probably who they are. But they are now becoming more the anchor tenants on systems than the traditional carriers that were in place. And they're buying capacity in unprecedented levels.
So I stopped by, we're here at the Data Center Dynamics Convention in London, and I stopped by the HP Enterprise booth yesterday, and they've got some custom-built servers and such for, and they disclose, Microsoft, Apple, Facebook, and others. And I asked him, how do you define where the carriers fit into that equation? Because he referenced their tier one customers are not the mobile phone companies, are not the telcos. They're really what was the term you used, web-centrics?
Yeah.
So it's the world has got a new pecking order. Well, next let's talk about WireIE. Rob, tell us, I want to get to the question, what are some of the constraints that you see in building networks in the urban versus remote areas? But let's start out by, who are some of your customers today, and what are some of the problems you're solving for them?
Well, most of our customers today are tier one carriers who work with us on a wholesale basis. They actually are still working with large enterprise and government customers. They need to make sure they have ubiquitous SLAs and service across all entities and assets, regardless of location. WireIE is a company that works well in that space. We're focused on it. It's an MEF certified network, carrier Ethernet 2.0. It's one of the only carriers that have that certification for a hybrid fiber-based network. And we actually are finding that our clients, who are wholesale, are kind of in a transformation with the web-centrics. They're looking at who's our new customer. But for WireIE, it's really about maintaining that core base for wholesale tier one carriers and making it so that things like video and unified communications and mission critical business applications can be used with a high availability, low latency network.
Got it. Well, Rory, let's talk about Xqueel.
Yes.
And I'm going to ask you a question about operating systems in a minute, but why don't we start with, who are some of your customers that you're working with today, and what problems are you solving for them?
Sure. This year has been a record year, of course. Almost all of our customers have been data centers, either new data centers, extending existing data centers, just new data centers, period. The unit of purchase is 10 Gs. We have 100G products available, but there's been no great demand this year because most people don't have 100G clients. So there's constant pressure to make better use of existing cable and constant pressure to link up all of these new data centers. We're prepared for some very complex network topologies, and we're not seeing them. People mostly want point-to-point. Sometimes they want something as clever as a loop. All the things we're prepared to give them, they don't want. They just want something fast, low cost, easy to install, easy to manage, fire and forget. And that's what our business has been this year. I'm surprised at the volume. We've had people write in from countries we've not got any presence in and say, we would like to order some for our data centers. And that is an unprecedented thing to happen. And I'm not sure I agree that with better efficiency we're going to be able to deal with all this, because from my point of view, I'm seeing more than a tenfold surge. I'm seeing customers whose demand has suddenly doubled, or they think it's going to suddenly double. It seems to be out of control. Most of the requests I'm getting are for increased capacity now, and I know the Cisco long-term numbers. I don't think those are as important as the short-term numbers, what each customer is facing. Each customer is facing a peak next month. And I don't know how guys are making these predictions.
Well, during our pre-call, you mentioned that things can be introduced to the network that fundamentally can cripple a carrier's network. And you mentioned the Apple iOS launch. What happened, and how did the carriers respond to that issue?
The carrier does the right thing and does their best to get all the packets through. What they often do is buy overcapacity to do that. Most people schedule their lines about 50%, so they've always got room for a peak. However, on some occasions, like when Apple introduced the last iOS update, everyone's peak got hit at the same time. So many people were upgrading their pads and stuff that traffic got blocked, and it got blocked for most of the data center's customers, not just for iOS. And the conversation was had was, how could you deal with that? And there are prioritization schemes that could be used, but they've not been necessary yet. But Apple never phoned everybody to say, by the way, Wednesday we're going to push this stuff through, and I just wanted you to know. It just came as a wham. There have to be ways in the future of dealing with these out-of-control things. There is no management for the internet. And so we actually need better traffic shaping. We need decent software in the transport systems to actually give priorities and assert them when these bad things happen. It's not a bad thing for iOS to come through, but they could have throttled it back. It wouldn't have mattered if the iOS update had taken all night. You were asleep anyway. It didn't have to take 2 hours.
Well, Jay, I want to talk about millimeter wave and how it relates to 5G, but first, why don't you maybe give folks an update on some of your customers, how you serve them, and what makes your service unique?
Yeah, sure. I know you mentioned wanting to talk a bit about the Jersey to Slough route, which is an interesting hybrid fiber wireless, albeit microwave, not millimeter wave. And we really focus on wireless technology, not just millimeter wave at its core. Just the difference being what level of spectrum you're playing in millimeter wave is the really high frequency stuff that's got lots of bandwidth, and I'll come back to that. But I think the route that we did via microwave, connecting New Jersey to Slough, is the absolute perfect metaphor for one of the verticals we're in, which is the low latency trading vertical. So we spent a little over 12 months designing, building, and lighting that thing up, and it was the absolute, cat's meow in the industry for exactly 12 months, and then this guy came along from the table in the ground that beat it. So, that is, it's funny when we first got involved with Jamie Scotto and her gang. One of the things that we always preach is that fiber and wireless need to cooperate. So as you look at, millimeter wave or microwave or fiber, and the statistics you gave at the very onset of this were really interesting. And I said this on one of these panels, I don't know, a year or two ago. If you look into the 20th century, bits are the new drug of choice. I mean, it's the new cosmetic thing that makes us all happy. And for us, low latency, that's just cocaine. So, people are going to need that sort of drive. And when you advance it into the origin of your question of millimeter wave technology, and NexxCom has gone through an interesting evolution in terms of how we look at technology and its development and what have you. And day one out of the gate, we were two guys in a truck effectively trying to figure out how to build wireless networks. We have 2 pennies to rub together, but we figured out how to build a couple. And we built for you guys, our customers. I mean, AT&T is one of our first and remains one of our longest standing customers. We've done the network for Branson Spaceport in New Mexico. 2 very different applications. One was oil and gas, one was the spaceship's got to go up, and I want to know all about it. And then, of course, one of our key verticals where latency is essential is the trading application, where these guys are just clamoring for their bit before the next guy. And it's a pony race from data center A to data center Z. Millimeter wave is an interesting thing because in terms of satisfying, or at least being a drug dealer in the metaphor that I'm using here in terms of the bit distribution, it presents a really interesting tool in that the guys that are putting fiber in the ground, and Greg can talk to this, I'm sure, because I know he just went through getting his express cable laid. It's not a small undertaking. I mean, but mind you, you got exabits or terabits, or you pick your funny word bits, you got a lot of bits. But I think what's important to know is there's a time to revenue and there's a time to difficulty to get that done. Where I think millimeter wave is interesting is it can close a cost per bit to deployment time gap between the two as a real complement. And also provide a redeployability and expansion in that bandwidth, because millimeter wave today is defined as spectrum between 70 and 90 gigahertz. We have internal development programs going on, and as again we've evolved, we used to build our own radios by hand, almost in a garage, and that worked for the year one. But by year 5 now, it's no longer quite relevant. We partner with equipment manufacturers and started to work with them because resource loading and what you're going to focus on is important. But millimeter wave, as it goes from 70, 80, 90 gigahertz to 120 and 240 gigahertz, will have a lot of the same principles, but what will happen is inside of one point-to-point radio, whereas in our microwave solution that ties New York to Chicago, that Greg just kicked its butt. Thanks, Greg. That was a 100 megabit surface. That's 100 megabits for 10 customers sliced up into 10 by 10 slices. Today's millimeter wave is 1 gigabit. Tomorrow's will be 10, but there is a clear trajectory to hundreds of gigabits per radio, where you can imagine for a very low cost, meaning thousands of dollars, not, what did it cost, 350 million?
$250 million for a transatlantic cable. Yeah.
So for a couple of $1,000s, I could put that same kind of capacity across the Hudson River and put terabits on roofs of data centers and offer diversity. So when the next Sandy happens or the next 9/11, God forbid, takes place, things will cause the wires to go down to keep the wireless up. And as we talk about latency into 5G, the one thing I'll just add on my closing point is 5G or a small cell, whatever you call it, you're going to have density of devices in the network, and the denser the network gets, the more digital signal processing events you're going to have to go through. And at some point, as dumb as we are as human beings, we're going to notice it.